recording. Right. Nope, that's chapter 6. Okay, so let's keep going now. Okay, so again, here we had this example. Here's another example, okay? So let's suppose, so it's just another quick example. I like to do calculations. Again, I'm not going through all those calculations as I did in this example with the table. What's nice is we don't have to. I mean, it's not as complicated too, because we have things like Excel and Google Sheets. Excuse me. But we have the formulas, which really help. But here, let's just say that, Mary, someone named Mary borrows $1,200 from a friend. And she says that she's going to pay it back at 8% simple interest for 7 years. Well, we can find out how much she owes, how much interest she owes. Basically here, what do we have? Our R, right? That's our percent, written as a decimal though. Okay, it's written as a decimal, right? The initial amount, the principal, P sub 0, 1,200. It's for 7 years, as you can see. So the balance, how much will be, show the balance at the end of 7 years, how much she'll owe her friend, right? This is how we calculate it. $1,200 times 1 plus 0.08 times 7, okay, which is the same as this, as you can see. And that turns out to be $1,872. So that's how much she owes, okay? And notice the amount of interest she owes is this, $672. So, okay. So that's just another example I wanted to do. This is simple interest. But there is another way to consider interest. It's what we call compound interest. This was simple interest, where again, each year the amount of interest doesn't change. As in this example as well. Now with compounding interest, or compound interest, I think is probably what I should have written, but let me give you an example to illustrate the idea. So let's suppose we're investing $1,000 into an account, okay? And the APR is 6%. We're going to say it's compounded yearly. You'll see what that means through these calculations. So basically, after 1 year, the amount is in the account, right? So at the end of that year, we have the $1,000 that we deposited, our principal. But this is what I was saying before. We're going to add on 6% of the $1,000. So I guess when we say invest, you could think of this account as like a savings account at a bank or something, like KeyBank around here. Okay. Then, so mathematically, we have 1,000 plus 0.06 times 1,000, right? 6% of 1,000, right? As we saw in the previous chapter, that's percent. Percent of a number. You basically multiply, converting the percent to a decimal. And we get this amount, which is, okay, which is this. For a second, I thought my math was off, but it's correct. So we get $1,060. So this is our interest, as you can see. Okay? But now, this is where it differs from simple interest. After year 2, as you can see, we have the $1,060 in there, right? We're going to calculate 6% of that. Right? We're going to add on, in other words, 6% of this new amount, as you can see. And you could probably guess, and you can see it here as well, the amount of interest is not going to be consistent. It's not going to be always $60. It's going to increase. Right? We have 6% of a bigger number. That means bigger interest. or more interest, if anything, 0.06 times this amount. And math, I did a little bit of rounding. I rounded 2 decimal places, although I guess here it's 1, it looks like. But anyway, I did round, and we get this. That's our interest. So altogether, we're going to have this amount here as our new, new amount in the account. Okay? So we're recalculating interest. That's where that's where simple and compound interest are different. And then we have a third year I threw in here for fun. It's the same idea again, same calculation. We have 6% of this amount, right? This is the new amount, right? Actually, let me say it again. This is the new amount in the account. We're adding on 6% of that. And, I just did the calculation here. 6% of it is 0.06 times this amount. And then I just did the calculation. You end up getting this. And then if you add it, you end up with this amount. So not only does the balance increase, the interest is increasing. Now, if we were to do this, for many years, we would have to do these calculations. But this is why I'm very happy we have Microsoft Excel and Google Sheet. This is actually what would happen. Let me make sure I'm not, okay. This is actually what would happen later on. So let's say we did this for 12 years for whatever reason, right? You can see the interest is increasing. And of course, the balances as well. Basically, at the end of a year, the ending balance becomes the starting balance for the following year. So this is what we would have if we did this for 12 years. Okay, that's pretty cool, right? We were earning a lot more than we would if we just did simple interest. And this is what they call compounding. Basically, every time you calculate the interest, you're compounding, so to say. You're compounding the account. I think that's what they say. Now, mathematically, this is the formula we're using. And yes, this is an exponential function, right? This thing here, 1 plus r over n, is our base, right? That's our b. The exponent is n times t. So we have a, that's the balance after t years. Generally for us, time is going to be years. I mean, really, I don't think it has to be, but for the most part for us, it's going to be years. Okay? T is, again, how long we decide, is in the years, as we can see. It's just time. T is time. Okay. We also have P naught. That's just like before. It's the principal. R, again, is our APR in decimal form. N is the number of compounding periods in a year. That's what N is. Okay. N, sorry, I thought something was wrong with the slides. N is the number of compounding periods each year. So what we did just before, the previous example, N in that case would be 1. It was compounded once a year. But you'll see, though, there are examples where you can compound twice a year, so once every 6 months. What's another one? 4 times a year, every 3 months, which I think they call it compounding quarterly. You could even compound daily, and in that case, your N would be 365. So thank goodness for calculators in that sense. Okay? Or monthly you can do. Okay? If I remember correctly also, we're actually assuming that we're not adding in more money or taking money out during this time period. That would make things more complicated. So, more things to consider. But this is compound interest is what we're doing here. Okay? So yes, we do have an exponential function. Now, can you compound more than daily? Turns out you can. We'll get to that. It's not in the book, but we do go into that a bit. It's not hard. It's really interesting, actually. It's fun. Okay, so anyway, that's what compound interest is. Let's see an example. So let's suppose we decide, well, we saw one example. Here's another one. Let's suppose we invest $3,000 into an account. It's paying 4% interest, and it's compounded quarterly. So we want to know how much will be in the account, how much the account will be worth, in other words, 15 years later. Okay. Now, before I go through the calculation here, although you can see it, let me just stop the recording